Hi, my name is Caitlin Buchanan. This is my science experiment presentation for Dr. Raz. All right, so let's get started. Science experiment, Caitlin Buchanan, mad scientist. My hypothesis is, what are the effects of the color of construction paper left in the sun for 1 hour and the temperature measured in Fahrenheit? I predicted that the blue construction paper would read a higher temperature on all 10 trials versus the yellow construction paper. That's my prediction. The content statement of this experiment, basically what my students and I are going to be investigating and researching is heat, light energy, light absorption, and reflection. So when an object absorbs light, like for example, this blue piece of construction paper, when it absorbs the light, it's going to hold the heat. So the light energy from the sun is going to transform into heat. So it's going to heat up this blue construction paper. However, when you have a lighter color, like yellow is a color that is known to reflect. So it's going to bounce the light energy wave off. So it's not going to hold as much heat. It's not going to absorb the heat. It's going to reflect the heat, versus the blue is going to absorb and have less reflecting. So my manipulated variable for this experiment is the color of construction paper. I have a blue and I have a yellow. My responding variable is the temperature. That's what I'm going to be recording. What's going to be changing is the temperature of the paper. My constant is the amount of time that I'm going to leave these colored construction papers outside, which is exactly 1 hour or 60 minutes. So the materials that you need is a pencil, data collecting sheets, 10 pieces of blue construction paper, 10 pieces of yellow construction paper, a thermometer scanner, temperature scanner, and a timer. You need a timer so you know when that hour is up. So for my procedure, I took 1 piece of blue construction paper, 1 piece of yellow construction paper. I put it outside on the sidewalk on a hot day, and I left it there for 1 hour. I set my phone timer for 1 hour, and at that point, when that timer went off, I went outside, I took my handy dandy temperature scanner, I pointed at the paper, and I got a reading in Fahrenheit. And then I recorded it on my data sheet, and I did the same thing with the yellow. I took my scanner, I pointed it, recorded in Fahrenheit, and recorded that data on my data sheet. And at this point, I disposed of trial 1, blue and yellow, and I got a brand new set of blue and yellow, and I put it outside for trial 2. And I repeated this process 10 times. My data sheet, data calculations, my cool graph that I made, and I color coded it blue and yellow. My results. My data showed that the blue construction paper, the majority of the time, there were a few times when the blue and the yellow read the same temperature Fahrenheit wise, but the majority of the time the blue did have a higher temperature than the yellow, and the yellow had a lower temperature than the blue. The conclusion is my prediction was correct. I predicted that the blue would absorb more light energy from the sun and transmit it into heat, and therefore it's going to read a higher temperature. My data did reflect that. The blue did have, majority of the time, a higher temperature read in Fahrenheit versus the yellow. Now, one really cool thing about this experiment is the real world applications. I'm really obsessed with conservation and the fact that you can put this knowledge into solar panels. So solar panels actually are painted a blue top coating. So the blue is for anti-reflective. It's a coating, it's an anti-reflective coating. And the purpose of it is to help improve the absorbing capacity and efficiency of the solar panels. I thought that was really cool. Here's a little tip for you if you ever want to make solar panels. Also, to relate this to students, when we go outside and you're wearing darker clothes, you're going to get hotter than when you wear lighter clothes, because the darker colors absorb the heat and lighter colors reflect the heat. And that is it. That is my science experiment. Thank you.